One of the other materials I'm using in my rig is cast epoxy. I had a failure on a part that was in my luggage at the airport, and it cracked off. This was attached to a long piece of aluminum and had a lot of leverage, and it just snapped. So the next decision was how to strengthen this or what to change the material to. Here's an identical unreinforced part. Let's see how much load it can actually take. First 5 kilos. $10 kilos. $15 kilos. Time to stand back. Well, it looks like I've gone ahead and destroyed all of my coupling joints, my stars here. As you can see, the threads were torn completely out at the back of this, and that happened on 3 out of 4 of my parts. So even if it's a cast metal, it's still subject to a catastrophic failure at this type of pressure. 15 kilos. 15 kilos. Alright, now it looks like we're overloaded here at the edge, so I'm going to have to put something in the middle here to take up the gap. Alright, I added a couple layers of PVC to see if I can take up a little bit more of the gap. 15. And 20 kilos. Alright, this makes 20 kilos. So apparently my fractured piece from the airport, that must have been subject to more than just load, but some high impact. Alright, now I'm going to try a piece with some fiberglass reinforcement. This is the same part, but I cast about 8 layers of fiberglass tissue in between the layers at the bottom, and then I cast over the top the top layer of solid epoxy. So let's see if this has any effect on the bending of the part. 15 kilos. Wow, I didn't expect that. The one with the reinforcement actually snapped, where the part that had no reinforcement bent. All right, well, I'll have another one. Let's give it another try. Okay, this part is virtually identical to the other one, except that it had dye in it. The difference this time, though, is that the reinforcement is now on the bottom. The extra cast epoxy was added to the top of it. So now our reinforcement's at the bottom instead of on the top. We'll see if it has any difference. 15 kilos. Okay, I had to go and add another layer of PVC to raise this up. 15 kilos. Too late. Okay, with 10 kilos, before I was able to even add the third weight, it fractured. So this is a pretty surprising result to me, that the original part that had no reinforcement actually flexed quite a bit and didn't break, and the ones with the reinforcement snapped. Alright, let's go back to the original piece of cast material and try it again. Now this one has no reinforcement at all. Let's see if we can make this one flex and break. 10 kilos, 15 kilos, at least my last star piece is holding out, and 20 kilos. Now before I push this one to failure, let's take it out and see if it will go back to its original shape. No, it does appear that it is permanently bent. Alright, for my last test I'm going to use a piece that I cast that has 10 layers of fiberglass reinforcement, and it has a double layer of epoxy that doesn't have reinforcement. Alright, let's put some weight on this thing and see what happens. And 20. Okay, although this is a double layer piece and it has 10 fiberglass layers, it still deforms under a severe load. It does seem to have returned to its original shape. It's a little hard to tell, but it's the way it is. Okay, well, what did we find out about our material from our experiment? It turns out that my unreinforced piece of a cast epoxy that has no fiber in it, it didn't break under all that pressure. Okay, second, under the same amount of pressure or less pressure, my reinforced piece of epoxy that had 10 layers of fiberglass tissue in it snapped. Okay, what's the third thing we found out? That doesn't matter whether the fiberglass is on the top or the bottom, it will fracture the same. And our winner is our double thick cast piece of epoxy resin, which contains 10 layers of fiberglass reinforcement, and this withstood a considerable load. It's quite lightweight, and I still have one piece intact that I can use to make a part, so we at least have one success story. So the one surprising story here is that my piece of cast epoxy that has no reinforcement in it didn't fail. It bent the limit, but it actually survived it, and this actually even has holes in it. So this just shows that the importance of testing your materials yourself so you actually know what's going on. I couldn't have predicted this. It surprised me.